120 volts. Out of that, 90 volts occurs across the 100 ohm. Therefore, what is the potential difference across the parallel combination? The potential difference across the parallel combination is 120 minus 90. Alright? The potential difference across the parallel combination is 120 minus 90 is 30 volt. Well, if 30 volt is the potential difference across the parallel combination, what is the potential difference across each of those resistors? What is the potential difference across the 100 ohm? Well, if resistors are connected in parallel, they will have the same potential difference, and that means the potential difference across the 100 ohm is the same as the potential difference across the 50 ohm, which is equal to 30 volt. Now, we can use that now to find the current in each of these. So the potential difference across the 100 ohm, I'm talking about this 100 ohm, is in the parallel network is 30 volt. And therefore the current in it is I equal to V over R. And that will be V is 30 volt, R is 100, so that will be 30 divided by 100, that is 0.3 ampere. Okay, now you tell me, if the total current is 0.9 ampere, and the current that goes in the 100 ohm is 0.3 ampere, what will be the current that goes in the 50 ohm? Well, that will be 0.9 minus 0.3, is that right? When 0.9 ampere comes here, 0.3 goes through 100 ohm, so the remaining must go through the 50 ohm. Alright. Now, since the total current is 0.9 ampere, the current in the 50 ohm is 0.9 minus 0.3 equal to 0.6 ampere. In fact, you can also obtain that by using the equation V over R. The potential drop across the 50 ohm is 30 volt, and so the current in it is 30 divided by 50, and that is also 0.6. You can actually go in any way you want to solve this problem. I want you to practice this kind of problems a couple more times and go and do all the homework problems. Alright, let's do one more. Find the power delivered to each resistor in the circuit shown on the right. What is the meaning of the power delivered? Well, the power in a resistor is the current in it multiplied by the potential difference. Is that right? P equal to V times I. Power delivered is voltage multiplied by the current. So we need to find the voltage and the current across each resistor and then calculate the. So to do that, first of all, let's find the total resistance of this circuit. What do we do first? Remember, the 3 ohm and the 1 ohm are a parallel circuit. So first we find the total resistance of that parallel combination. What is the total resistance of 3 ohm and 1 ohm connected in parallel? You can do that mentally. The total resistance of the parallel combination is 3 times 1 divided by 3 plus 1. That will be 3 over 4 or 0.75 ohm. So this combination has a total resistance of 0.75 ohm. And now, this 2 ohm, and this is 0.75 ohm, and the 4 ohm are all in series. They are now end to end. Alright? So the total resistance of the network now is 2 ohm plus 0.75 ohm plus 4 ohm. That will be 6.75 ohm is the total resistance. Alright, If you know the total resistance, what is the total potential in the circuit? It's 18 volt. Can you calculate the total current in the circuit? The current in the circuit is I equal to V over R. The total current I is the total potential V divided by the total resistance R. Our total potential is 18 volt. Total resistance is 6.75 ohm. That is 2.67 ampere. Okay, from the understanding we developed from doing problems previously, can you tell me if the total current is 2.97 ampere? What that means is the amount of current that comes out of the cell is 2.67 ampere. That means all of that current goes through the 2 ohm. When it comes here, part of it will go through 3 ohm, the other part will go through 1 ohm. They will combine to become 2.67 here, which will pass through the 4 ohm and back to the cell. That's what it means. That means the current in the 2 ohm and the current in the 4 ohm will be the total current 2.67. So the current in the 2 ohm is 2.67 ampere. The current in the 4 ohm also is 2.67 ampere. Now, let's now find the potential difference across each of these resistors. You see, our task now is to find the current in these resistors. In order to do that, we need to find the potential difference. Now, we know that the total potential is 18 volt. If you know the potential difference across the 2 ohm and the 4 ohm, we can take that away from 18, which will give you the potential difference across the parallel combination. That's our aim. So, the potential difference across the 2 ohm, can you tell me what will that be? V equal to I over R. Oh, did I say V equal to I over R? V equal to Ri, where R is 2 ohm, I is 2.67 ampere, and that is 5.3 volt. So the potential difference across the 2 ohm is 5.3 volt. And so what is the power delivered to that 2 ohm resistor? The power delivered is V times I, and you know the potential difference is 5.3 volt. You know the current is 2.6 ampere. So the power delivered to this resistor is 14.2 watt. Alright, now let's go and find the potential difference across this 4 ohm. The potential difference across the 4 ohm will be V equal to Ri, R equal to 4 ohm, I is 2.67, and that is 10.7 volt. Okay, and therefore what is the power delivered to the 4 ohm? Power delivered is V times I. So P equal to V times I, where we just calculated the potential difference is 10.7. I is 2.67 ampere. So the power delivered to the 4 ohm is 28.6 watt. Now what is the potential difference across the parallel combination? We know the potential difference across the 2 ohm. We know the potential difference across the 4 ohm. Add them together and take it away from 18. That will give you the potential drop across the parallel combination of 3 ohm and 1 ohm. So that will be 18 minus 5.3 plus 10.7. That is 2 volt. So the potential difference across the parallel combination is 2 volt. It means, if you now know that if resistors are in parallel, they will have the same potential difference. So the potential difference across the 3 ohm is 2 volt. The potential difference across the 1 ohm also is 2 volt. So potential difference across the 3 ohm is 2 volt. and therefore the current in it, can you calculate the current now? Current I equal to V over R, and that is 2 volt divided by 3 ohm is 0.67 ampere. There you are. So 0.67 ampere is the current there. And what is the power delivered to the 3 ohm resistor? The power delivered to the 3 ohm resistor is P equal to V times I. V, the potential difference is 2 volts. The current is 0.67 ampere. That will be 2 times 0.67. That is 1.34 watt. Okay, now can you tell me what is the current in the 1 ohm therefore? When 2.67 ampere reaches here, 0.67 goes through the 3 ohm. That means 2 ampere must go through the 1 ohm. So the current in the 1 ohm will be 2.67 minus 0.67, that is 2 ampere. Okay, now tell me what is the power dissipated in the 1 ohm. The power dissipated in the 1 ohm will be the potential difference across the 1 ohm multiplied by the current in that. Right. So the power delivered P equal to VI, that is 2 volt multiplied by 2 ampere, that is 4 watt. Now, what is the total power delivered to all the resistors? If you add all that, that will be the total power delivered to all the resistors. And the total power delivered to all the resistors must be equal to the total power supplied by the battery. The battery is supplying the power, the resistors are spending it. Isn't it? The power is dissipated in the form of heat, light, and so on. What is the power supplied by the battery? The power supplied by the battery is the voltage of the battery multiplied by the current that it supplies. What's the current the battery supplies? 2.67. So 18 multiplied by 2.67 is the total power supplied by the battery. Can you do that and let me know if we got it right? If we got the problem right, then the total power supplied by the battery must be equal to the total power consumed by each of the resistors. I'm going to leave it for you to do and let me know how that looks like. We are now going to look at an important concept in electric